So first thing about OSPF routing protocol is it is an open standard protocol. Means we can run this protocol on Cisco devices also and on non-Cisco devices also. OSPF stands for what? Open
Shortest
shortest
path first.
path first. Path first. Guys, open means it is an open standard, and shortest path first is an algorithm that OSPF use for best path selection. Like EAGRP uses dual algorithm, OSPF using SPF algorithm. SPF, shortest path first, it is an algorithm, and open means it is an open standard. So this is meaning of OSPF. After that, third point about OSPF routing protocol can be it is it is an IGP protocol. It is an IGP protocol, means it will work within autonomous system number within AS. Here autonomous system is area. We will discuss in upcoming day about the area concepts in OSPF also. For now it is an IGP protocol. After that it is a link state routing protocol. Link state routing protocol. Then we can say what protocol number OSPF uses. It uses protocol number
89.
89.
89. Very good. Then it uses two multicast address. Uses two multicast
224.0.0.5.
addresses. Yes, 224.0.0.5
5.
and
And
224.
6. 6.
224.0.0.6. Okay, we'll discuss when it will use this multicast address and when it will use this multicast address. There is concept of DR and BDR. We will understand it in upcoming day. But OSPF is the first protocol till now we are learning which is using two multicast address. Like EAGRP is using one multicast address, RIP version 2 is using one multicast address, but OSPF is using two multicast addresses. Okay, it uses which algorithm? SPF algorithm. It uses SPF algorithm for best path selection. Then what we can say about OSPF? Metric over here is metric in OSPF is cost, and formula to calculate cost is reference bandwidth. Reference bandwidth. Reference bandwidth is just predefined bandwidth. That is by default it is 100 on Cisco IS. So formula to calculate cost is reference bandwidth divided by bandwidth of link. Bandwidth of link. So if I will talk about cost on fast Ethernet link, cost on fast Ethernet link will be what, guys? What will be cost on fast
100 by
Ethernet?
100 it will be 1.
Yes, cost
It will
on
be
fast
1.
Ethernet link will be 100 divided by 100, because by default reference bandwidth is 100 and bandwidth of fast Ethernet link in Mbps is 100. So 100 divided by 100, it will be 1. So you will see OSPF will always calculate cost 1 on fast Ethernet link. If I will talk about OSPF cost on Ethernet link, then what will be the cost on Ethernet link? Cost equals Again 100 divided by
10.
10.
Yes.
10 Mbps for Ethernet link, right? So here on Ethernet link, OSPF will calculate cost 10, and on serial link, bandwidth of serial link is, if you will calculate cost, we'll discuss what will be the cost on serial link. But for now, I am saying cost on serial link will be 64. Cost on serial link. Fine. So OSPF will calculate these cost on these interfaces or on this type of link. OSPF is a link state routing protocol. Here let me mention reference bandwidth also. By default, by
And for
default,
loopback also, it is cost is 1, right?
right. By default reference bandwidth is 100 Mbps. Fine. So these are some basic points about OSPF routing protocol. Okay, guys. Hope it is clear. Fine. So here you can see in OSPF, metric calculation is very easy. Metric calculation is very easy. In EIGRP, we need to use formula 10 raised to power 7 upon least bandwidth plus total delay upon 10 whole multiply by 256. But in case of OSPF, it is easy, right? And OSPF is a link state routing protocol. So you can see it is using link property only to calculate cost, right? It is not using like hop count, like distance vector routing protocol, RIP, or other distance vector routing protocol, RIP version 1 and version 2. Now in OSPF we have some types of messages. Let me discuss that also here. Types of messages in OSPF. So how many types of messages are there? Anyone? In OSPF? Yes, number one is type 1 message. Type 1, that is hello message. Here also use of hello messages. There are two use of hello message. First one is DND and second one is keep alive. Keep alive. Dynamic neighbor discovery, to discover neighbor, and keep alive, like EIGRP or reversion 2. Hello message is used to discover neighbor and keep alive. Okay, then second message is type 2 message in OSPF is type 2 message is second type of message, that is type 2 message. Type 2 message is called DBD. DBD, database description. See, OSPF is a link state routing protocol, and you know link state routing protocols maintain three tables. Number one is neighbor table, second one is database, and third one is routing table. So this is one type of message, DBD, database description. Like menu card, menu card of a hotel. Menu, in the menu card there are name of food, but they are not actual food. Okay, so DBD will also carry the description of actual database. Fine. So this is second message in OSPF. Third message in OSPF is type 3 message. Type 3 message, that is LSR. Type 3, that is LSR. Link state request message. We will discuss working of each message, right? For now, just understand how many types of message are there. LSR. Fourth type of message in OSPF is type 4 message. Type 4 message, and type 4 message is LSU, link state update message. Fifth message in OSPF is type 5 message, that is LSAC, link state acknowledgement. So there are 5 types of messages in OSPF. Okay, we will discuss all messages one by one. Fine, clear? Okay, first one is hello message. hello. So to discover neighbor, right, and keep alive. This is the second use of hello message. First is discover neighbor and second one is keep alive. After that, router will send hello message on multicast address also and on unicast address also. Like in EIGRP, we understood there are two types of neighborship: static neighborship and dynamic neighborship. In dynamic neighborship, EIGRP sends hello message on multicast address. In static neighborship, EIGRP send hello message on unicast address. Right. In the same way, in OSPF also we have two types of neighborship: static and dynamic. In case of dynamic neighborship, OSPF will send hello message on multicast address. In static neighborship, OSPF will send hello message on unicast address. Okay, so it will send hello message on what multicast address? Multicast address is 224.0.0.5, or it can send hello message on unicast address. Fine. Okay, hello message is used to discover neighbor and keep alive. Hello message will be sent on multicast address 224.0.0.5 and on unicast address in case of static neighborship. In case of static neighborship. Static neighborship. Fine. After that, if I will talk about the content of hello message will carry what informations? Okay, so here we can say contents of hello message. Okay, this hello message will carry information of version, which version of OSPF we are running on router. So there will be information of version will be 2. The after that, types of message. So this is type 1 message, so there will be information about type, so it is type 1 message. Then there will be information about the length also, length. And after that there will be information about the router ID. This is important, let me write only important information, not length. Here there will be information about router ID. Router will share router ID, and see, in OSPF router ID is compulsory. Here you have to configure router ID also. If you will not configure router ID, it will elect router ID automatically. So we will understand that process also, like how routers will elect router ID automatically. Like router ID is one unique identity of router in IPv4 format. In IPv4 format, so IP address of a physical interface or IP address of a loopback interface can be the router ID, or manually we can define router ID in IPv4 format, right? And hello message will carry router ID information, version, router ID, type of message. After that there will be some more information. Checksum field is also there in hello message. Authentication, if we have configured authentication, so authentication type will be there, authentication data will be there. After that, subnet mask will be there, subnet mask, because authentication is optional, so that's why I am not mentioning authentication here. Subnet mask. After that there will be information about date time and hello time, date time and hello time. After that there will be information about priority, we will see this option also. Then there will be information about dr router id, dr router id. After that there will be information about bdr router id, bdr router id. After that there will be information about neighbor router id, neighbor router id. Then there will be information about Okay, so these are, let's say, important information, right? That one hello message will carry these all information. Fine. Out of these all information, some information should be match and some information should be unique. So what are the parameter, right? If like in EAGRP, if ES number will match, then only neighborship will come up. Otherwise EAGRP neighborship will not come up, because if we are configuring EAGRP between two router and both are using different ES number, then they cannot become neighbor. So here also in OSPF we have neighborship parameter. So let me discuss neighborship parameter here. So these are, first of all, let me do one
Sir,
thing.
what is the size of the hello packets?
Size of the hello packet, I don't know, brother.
Okay, so it is between the 20 bytes to 24 bytes, something I need to check actually.
Okay, we can check it later. Okay, now out of these information, see what are the parameter. Neighborship, neighborship parameter. First, router ID, router ID must be unique. Router ID must be unique. Let's say we are running OSPF on two router. Here I have R1 and here R2. R2. Let's say here I have configured OSPF router ID 1.1.1.1, and on router number 2 also we have configured same router ID 1.1.1.1. So OSPF neighborship between router 1 and router 2 will not come up, because both router is using same router ID. So first requirement of OSPF neighborship is router ID must be unique in OSPF domain. Fine. So here router ID should be 2.2.2. Okay. Then hello time and date time must be same, must match. In EIGRP, hello time and hold on time can be different, can be same, right? Doesn't matter. It is not in neighborship parameter. But in case of OSPF, hello time and date time must be same on both router. Let's say on router number 1, hello time is 5 second and hold on time is 10 second, right? And on router number 2, hello time is 5 second and hold on time is 15 seconds. So again OSPF neighborship will not come up here, because hello time and date time on both router is not same. So hello time and date time should be same on both router, then only OSPF neighborship will come up. So second parameter is what is happening. Okay, hello time date time must be same, must be same on both router. After that, subnet should be, subnet mask must be same. Definitely subnet mask should be same. Subnet mask should be same, definitely. Then MTU, MTU must be same. Let's say on router number 1 MTU is 1500 byte, and on router number 2 here MTU is 1400 byte. Again OSPF neighborship will not come up, because MTU is also one parameter of neighborship. So if MTU is same, if MTU is matching on both routers, then only OSPF neighborship will come up. That means hello message will carry MTU information also. hello message will carry MTU information also. Then MTU must be same. After MTU, if you have configured authentication, so authentication type and authentication data must be same. After that, stub flag are there, so that should be same, but we will discuss that later. Area ID should be same. OSPF work on the basis of area, so area ID must be same. Like on daughter number one, let's say we have advertised this interface in OSPF area 0, and this interface is in area 1. So again OSPF neighborship will not come up between daughter 1 and daughter 2. Both side area ID should be same. Area ID must match. So these are parameter, neighborship parameter. And here we can say network type also. Network type must be same. Network type must be same. Okay, so these are OSPF neighborship parameter. Any doubt till here? Any doubt till here to anybody? What are the OSPF neighborship parameter? Router ID must be unique. Hello time, date time must match. Subnet mask must match. MTU must match. Area ID must match. And network type must match. There are several types of network in OSPF. We will discuss it later. But when we will discuss network type, you will see if network type is not matching, then neighborship will not come up. Fine.
Sir,
So by default, router ID will be unique, right?
By default, router ID will be unique.
Unique only, right?
Yeah, by default, let's say on router we don't have any IP addresses and we are configuring OSPF, so it will not elect any router ID. They need one IPv4 address for router ID. So maybe
No,
on
like
both router we are running one loopback, and on loopback we have same IP address, so both router will elect same router ID. Now, how router will elect router ID? This is question C. Now, next topic is router ID. Okay, this is basic things about OSPF neighborship. We discussed.
Jay, I think for creating that neighborship means for that establishing that neighborship also, I think authentication also should be must match, right?
Yes, authentication. If you have configured the authentication, so authentication type and authentication data both should be match.
Yeah, that one also actually that is also one parameter, right? To
Yes,
establish that
that is
neighborship.
also, but that is optional. If we have
Okay.
configured it, then it should be match. If we have not configured it, we can ignore it. But these are the compulsory parameter that should match.
Okay, Jay. Thank you.
Now see here, in GNS3 I have one small topology. Let me try to configure OSPF on R1 without configuring any IP address on any interfaces. See what this router is. Yes.
Hello, G. Can we use the IPv6 address for the OSPF?
For IPv6 we have OSPF version 3. Now we are learning OSPF version 2. Okay. In OSPF version 3 also you need IPv4 address as a to use router ID, not IPv6 address.
Okay, V3 also we require the IPv4 address.
V4, yes. If you don't have IPv4 address on any interface, then you have to manually specify router ID there in case of IPv6 network. Okay.
We can use IPv6 if it is router ID is not available. Manually, we can configure the router ID of IPv6 address as a router ID.
No, we cannot configure IPv6 address as a router ID, na? We can configure only IPv4 address as a router ID.
Okay.
So here if I will try to configure router OSPF, let's say process 1, and see the message. Here it's saying OSPF process 1 failed to allocate unique router ID and can't start. So you cannot configure OSPF here because on this router there is no any IPv4 address configured, right? So that's why this router is not able to allocate router ID. So here manually we can define now router ID 1.1.1.1. We can say router ID 1.1.1, but here I have not defined any router ID and there is no any IP address on interface. If I will check show IP protocol, here you can see show IP protocol, router ID is 0.0.0.0. So sometime interviewer can ask you this question that if we don't have any IPv4 address on any interface of router and we have run this command router OSPF process ID, then what will happen? Router will elect what IP address as a router ID. So 0.0.0, right? And router never run OSPF process with router ID 0.0.0. Fine. So here we can do what? We can manually specify router ID, or we can configure IP address on any physical interface or an loopback interface. So see first what is the process of electing router ID. First of all guys, we have two methods to configure router ID on router. We have two method, two option to configure router ID on router. First one is static. First one is static router ID. First method is static method. Static. In static, simply you can run this command router OSPF process 1 and router ID 1.1.1.1, right? And so IP protocol, you can see now router ID is 1.1.1. But if you will not define router ID here, and now if I will remove this command router OSPF 1 and I am going to say no to this command, will again router ID become 0.0.0? Yes, tell me guys.
No.
So
No,
it will elect the highest IP or something, right?
until and unless we will not reload this OSPF process, router ID will be 1.1.1.1, right? Once router will elect one IP address as a router ID, it is not going to change their router ID until and unless we will not reload the process. So
Okay.
IP protocol, you
During
can
the
see
process
router
also
ID,
it will not work, right?
right? So you can see still router ID is 1.1.1. So this is the manual process. Here I am going to, let's say, reload the router. Now, second method is dynamic. If we will not configure router ID, then what will happen? So dynamic method. Router will look up loopback interface. Router will look up loopback interface. First is loopback. Router will check loopback interface, and if loopback exists on router, then IP address on loopback interface will become a router ID of OSPF. If there are more than one loopback exist on router, then highest IP address of loopback interface will become router ID of OSPF router. If loopback is not exist on the router, then it will check physical interface IP address. If there are multiple physical interface on the router, then highest IP address of physical interface will become router ID of OSPF. So first it will check loopback interface, highest IP address on loopback interface, highest IP address of loopback interface will become router ID, right? And if loopback is not exist, then highest IP address of physical interface will become router ID. Fine. Okay, so see here on this router, let's say I am going to create one loopback here, 1.1.1.1. This is loopback 1, where I am running this IP address 1.1.1, and there is one more loopback, let's say loopback 2, there I am running IP 2.2.2.2. So which IP address will be elected as router ID on R1?
2.2.2.2.
2.2.2.2. And here on this physical interface we have this IP address 12.1.1.1. So let's say loopback is not exist on R1, then what IP address will become router ID here?
12.1.1.1.
F.1.1.1.
And if router 1 have one more interface where I am running this IP address, let's say this router have one more interface, fast Ethernet 1/0, here I am running 23.1.1.1, then
23.1.
yes,
23.1.1.
highest IP address. And now let's say here we have one physical interface where I am running this IP address 12.1.1.1. I have enabled OSPF, so this IP address is elected as router ID. And now if I am creating loopback again, here now I am creating loopback, these two loopback, will OSPF change their router ID?
No.
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 No,
No.
right? So once OSPF will elect one IP address as a router ID, it is not going to change. Even you are configuring loopback interface with higher IP address. Yes, there is one another way, that is manual configuration. Manually we can change it. But if router have already elected one router ID and you are manually changing it, then you have to reload the OSPF process. Why? Because all OSPF router represent their database with router ID. Like router 1 will also maintain their database, router 2 will also maintain their database in OSPF, and router 1 will represent their database with router ID. Let's say 1.1.1.1 is the router ID of router 1 and 2.2.2.2 is the router ID of router 2. So both are representing their database with their router ID and both will exchange their database with each other. Right? Router 1 will share their database to router 2 and router 2 will share their database to router number 1. So actually router 2 have shared their database with what router ID 2.2.2 to router number 1. That is the reason why you are not allowed to change router ID here on router number 2, because router 2 is saying I have already shared my database with this router ID and now you are changing router ID. This is not possible, right? If you want to change router ID, first reload the OSPF process. Okay, so this is concept of OSPF router ID. What happened here? Why it's not working? Okay, so on this router, let me create one loopback interface, loopback 1. IP address is 1.1.1.1, 255.255.255.255. Here I have only one loopback, that is loopback 1, and I am going to create one loopback on router number 2 also. Loopback 2 IP address on this loopback interface, sorry, loopback 1 here also, loopback 1 2.2.2. So now on router number 1 I am going to configure OSPF. Command is very simple, router OSPF process 1, that's it, and go to router number 2, and I think I have not created loopback here on router number 1. Do so IP interface brief, yeah, loopback is there. So IP protocol, you can see router ID of router 1 is 1.1.1. In the same way on router number 2 interface loopback 1, IP address is 2.2.2.2, 255.255.255.255, exit router OSPF 1, and manually also we can define router ID 2.2.2, or if you will not define manually, it will elect router ID automatically. So IP protocol, router ID is 2.2.2.2. And see, on router number 1, if you will check database, so IP OSPF database, so inside the database we are not able to see any LSS here because we have not advertised any network, and there is no neighborship between router 1 and router 2 because we have not advertised this interface in OSPF on router number 1 also and on router number 2 also. Fine. So any question guys in OSPF router ID?
Sir, if
Yes,
are you hear me?
yes.
Sir, if the router 2, yes, if the router 2 loopback is configured 1.1.1, then
Okay,
OSPF neighborship will.
see, no router OSPF 1, I have removed OSPF configuration. Now router OSPF 1
Okay.
and router ID 1.1.1.1, right? And now I am going to advertise the fast Ethernet 0/0 of both router in OSPF, router OSPF, or simply we can enable OSPF on interfaces basis also, like on interface fast Ethernet 0/0. IP address is 12.1.1.2, 255. 255.255.255.0 and IP OSPF 1 area 0. Let's say I have advertised it in area 0, and on router number 1 also config T interface fast Ethernet 0/0 IP address is 12.1.1.1 255.255.255.0 and IP OSPF 1 area 0. Wait. So IP OSPF neighbor. So IP OSPF neighbor. So IP OSPF interface brief. So OSPF is enabled on fast Ethernet 0/0 where IP address is this one. State is down. So IP interface brief exclude unassign. Fast Ethernet 0/0 administratively down. Interface fast Ethernet 0/0 say no set. And so IP OSPF interface brief. Yes. So IP OSPF neighbor.
In R2 also we need to give no shut. I think you missed it there.
So IP interface brief exclude and assign. Interface fast Ethernet 0/0 no set. So IP OSPF interface brief. State is waiting, both router will become DR. And see here the log message. OSPF detect duplicate router ID 1.1.1 from 12.1.1.1. This is the error message on router number 2, and on router number 1 also you can see getting same router ID from 12.1.1.2 on fast Ethernet 0/0, right? So as I told you, neighborship parameter is router ID must be unique. Because of that, so IP OSPF neighbor. So there is no OSPF neighborship because of router ID. When router 1 is sending their hello message, it is sending their hello message with router ID 1.1.1, and router 2 is checking their on router ID and the router ID which is coming in hello message. Both are same. So it is giving you this duplicate error. Duplicacy error. Fine. Simply what we can do on router number 2, we can change the router ID. Router OSPF process 1, we can say router ID 2.2.2.2. So IP protocol. Router ID of this router is now 2.2.2. And now you can see OSPF neighborship is in full state. So IP OSPF neighbor. Fine. Who is neighbor? 1.1.1. State is full. This router is DR and these are timer. address, on which interface. These are information. Fine. So if you have configured same router ID on two router, it will give you duplicacy error. That's it. Now how OSPF routers is going to become neighbor? See, in OSPF there are two types of neighborship. One neighbor without adjacency and one with neighbor with adjacency. OSPF routers share their database with adjacent router only, not to neighbor, right? One neighbor can be till two-way state. For that you have to understand actually neighborship state. So let me discuss first neighborship state in OSPF.
Sir, before that, I have a question, like a little
Yeah,
doubt.
yeah, go ahead.
Earlier, you mentioned about once a OSPF selects a router ID, then if you change, you have to reload the router.
Correct. Now you can see here router have exchanged their database. See on R1 we can see the database. So IP OSPF database. There is one database of router 2, 2.2.2, right? Now you are not allowed to change router ID. Let's say on router number 2 I am going to configure router ID 3.3.3, router OSPF 1 and router ID 3.3.3.3. What it's saying? OSPF reload or use clear IP OSPF process command for this take effect, to take effect. Otherwise still OSPF process ID is 2.2.2. So IP protocol. So when you will reload OSPF process, then router ID will become 3.3.3 until and unless router ID will be same 2.2.2, because we are not able to change the router ID now. Clear, Kesav?
Yes, sir. Thank you.
Sir, regarding this process ID, so is it mandatory? Like,
process ID is locally significant. We can run more than one process on a single router. We can run more than one process of OSPF on a single router. That's why we have process ID.
like for between the two routers, if we use different
It is
process
locally
ID,
significant. We can
so it will not impact.
configure same also. We can configure different also.
So it will not impact if it is different.
No, no.
Okay.
It is locally significant.
Okay,
Fine.
sir.
Now next topic is OSPF neighborship states. And guys, this is very important for interview perspective. Many time interviewer can ask you question from OSPF neighborship state. So first understand how many types of states are there. Then we will discuss all states one by one. First one is down. Neighborship states. First one is down state. Second one is, yes guys, second one is init. Third one is attempt. Generally you will not see attempt state. Fourth one is two-way, very important state, two-way. Fifth one is x start, I think, yes, x start. Sixth one is exchange. Seventh one is
Full.
loading na brother. And then eighth one is full, right? So if I will remove attempt from here, so this one is we will discuss attempt later. Third one is this one, fourth one is this one, fifth one is this one, sixth one is this one, and seventh one is this one. Okay, so we need to understand these 7 states of OSPF. Okay, as I told you, there are 2 types of neighborship in OSPF. There are 2 types of OSPF neighbor SIP. First one is neighbor without adjacency. Neighbor without adjacent. And second one is neighbor with adjacent. Fine. Neighbor with adjacent means full neighborship. Full neighborship.
Actually, we saw the wait status earlier when we run the previous commands. We saw the wait.
That was not a state, brother. That was not a state. That was DR and BDR election state. That is different. Don't worry, you will understand it. Now, first one is down state. What is the meaning of down state? Let's say I have two router, R1, R2. R1, R2. Here we have enable OSPF. Let's say router ID of this router is 1.1.1.1 and router ID of router 2 is, let's say 2.2.2. So after running OSPF on both router R1, let's say on router number 1 we have just enabled OSPF. So router 1 will start sending hello message from this interface. It will send their hello message. Hello message. And let's say we have not enabled OSPF on router number 2 till now. So router 1 will not receive any hello message on this interface. Let's say this is F0/0. F0/0. So router 1 is doing what? Router 1 is only sending hello message from this interface. It is not receiving any hello message on this interface. So till now, state of this interface will be considered as down. Down interface means we have enabled the OSPF on that interface, but router is not receiving any hello message. Router is not receiving any hello message. Fine. Okay, clear? Down state means router is sending hello message, but it is not receiving any hello message on the interface. Fine. After that, when I will configure OSPF on router number 2, router 2 will also send their hello message, right? It will also send their hello message. Router 2 will also send hello message to router number 1. Once router 1 will receive the hello message on fast Ethernet 0/0, state of this interface will move to init. From down to init. Init means initialization, right? Once router will receive any hello message on any interface, state will move from down to init, right? And you know hello message will carry what informations? It will carry like router ID, neighbor router ID, right? So in first hello message of router 2 or in first hello message of router 1, there will be router ID of router, but there will be no information of neighbor router ID, because till now router 1 don't know who is the neighbor, right? So in the first hello message, both router will send their own router ID, but it will not share their neighbor router ID. So neighbor router ID field will be empty in the first hello message. Okay, just 1 minute, guys. Okay, so till here any doubt, any question till here?
Mr. Ji, it's a general question. When we use the OSPF, why we use the OSPF?
Why we use the OSPF? Why we use any routing protocol? For the routing,
Okay, routing purpose.
select best path.
What are the cases? What are the cases? Why don't we go for EAGRP or some other is there, na? Why we using the OSPF? What are the advantage?
What are the benefit of OSPF over EAGRP?
It's not a
What are the
Cisco priority.
No. As you know, EAGRP is an
Cisco priority.
no routing by rumors are there, na?
Yes.
All routers are depend on their neighbor. But in case of OSPF, all routers will have complete view of topology. As I told you when we were discussing about types of dynamic routing protocol. In link state routing protocol, I told you that link routing protocol router will have complete view of topology. One single router can design the entire topology by checking their database, which is not possible in case of distance vector routing protocol, which is not possible in case of EIGRP, RIP. So don't know why you are asking now this question that why we are using OSPF. Okay, by the way, brother, here benefit is link state routing protocol router will have complete view of topology. Routers are not dependent on their neighbor, right? Each router have, in EIGRP there is query message. Why there is query message? Whenever successor path will goes down and feasible successor is not available, router will generate query message to ask to their neighbor. Why? Because router don't have information about alternate path. But in case of OSPF, you will see if there are, between source and destination, if there are 4 paths. So router will have information about all path. And out of that, it will use one.
Actually, in this case, so we are getting the more path and more details, but this is will affect to the router, na? Router will use the more resources like
CPU resource.
Router. In OSPF, definitely router will use more CPU in case of OSPF. It is maintaining database here. But benefit is what? It will have complete view of topology. And this is the reason why we are using OSPF nowadays. Why we are not using EIGRP.
in
Because
real time, which cases we can select small network segments or larger network segments? In which cases we'll select OSPF?
in a small network also you can use OSPF, but in a small network recommendation is a static routing, so that we can save the CPU utilization, because in a static routing we don't need CPU to run the routing protocol, because their routing protocol is not required. Simply we can define manually, we can define the routes on a routing table in the routing table of router. But here we are running routing protocol, so if network size is large, then you should use routing protocol, otherwise you should use a static routing. If you can use RIP routing protocol in your network, that is much better as in the perspective of CPU utilization.
And for this routing protocol, we can use on cloud also. Can we use?
In cloud?
Yeah.
Yes, in cloud also. Of course. In cloud also, let's say you have deployed 2 router on the cloud and both are directly connected with each other and both have 100 prefixes. So you need to exchange 100 prefixes with each other. Definitely you have to configure one routing protocol, or you can configure 100 prefixes statically.
Okay, got it. Thank you.
Okay. So here see, in the first hello message of router 1, router will share their on router ID 1.1.1.1, and in the hello message of router 2 will also send their on router ID 2.2.2.2. Fine. So the state till now is init. When router will see their own router ID in the hello message, state will move from init to two-way. When router will see their own router ID. Now, see, router 1 have received one hello message from router number 2. So now router 1 know what is the router ID of my neighbor 2.2.2. So in next hello message, router 1 will see here their own router ID also and their neighbor router ID also. My router ID is 1.1.1.1. My neighbor router ID is 2.2.2.2. When router 2 will see their own router ID in the hello message, their state will move from init to two-way. their state will move from init to two-way. Got it? In the same way, router 2 will also send hello message, and in next hello message it will share their own router id as well as neighbor router id. Their own router id is 2.2.2.2 and their neighbor router id is 1.1.1. So here fast ethernet 0/0 of router 1 state will move from init to two-way. And guys, in two-way state, you know, in two-way state router will check something, like router will check bidirectional connectivity. In this state, bidirectional connectivity is checked. DR BDR election will happen here. You know, in upcoming day, in maybe next video, you will understand what is DR and BDR, why we need DR and BDR in the topology, right? Which router is going to become DR and BDR. Like here also you can see in this scenario, one router is DR and one router is BDR. Here, so IP OSPF neighbor. So you can see 1.1.1 is DR here. 1.1.1 is DR, and on router number 1, so IP OSPF neighbor. 2.2.2 is BDR, backup designated router, right? So DR BDR election will happen in two-way state, in this state. Fine. One router will become DR, one router will become BDR, all other routers will become DR other. So we will discuss DR and BDR state later. Fine. After that, next state is, after DR and BDR election, state will move in X start state. In X start state, router will exchange sequence number. Let's say here I have again two router 1, router 2. R1, R2. Let's say router 1 have some network, router 1 have one database. Inside the database there are some network, let's say A network are there, A, B and C. Three networks are there inside the database of router 1. Let's assume this is database of router 1, and in the same way router 2 have also one database, and inside the database of router 2 there are some network information, like inside the database there are three network X, Y and let's say Z. Fine. This is database of router 2. Database of router 2. In X start state, what these two router will do, these two router will exchange DBD, type 2 message, DBD, database description. Router 1 will send their DBD message, DBD, and router 2 will also send their DBD to router number 1. It will not actually carry all information of database. This DBD message will just carry header of database. Let's say there are detailed information of A, B and C. There is detailed information of X, Y and Z. But this DVD message will just carry overview like A, B and C. I have these three network. Router 2 is saying I have these three network X, Y and Z. Right? This is not detailed information. Just an overview of database. Fine. In X start state, router will exchange DBD. Through DBD, it will just share header of database. You can say header of database. And in this state, in X start state, through DBD message, both router will exchange what sequence number also. Let's say router 1 is sending DBD message and inside the DBD message there are headers of each networks, and let's say it is sending sequence number what 1, and router 2 is sending sequence number what 2. So both router have exchanged sequence number, means router 1 have received one DBD message from router number 2 with sequence number, both are sending let's say sequence number 1, so 1, right? So last message that router 1 have received from router number 2 with what sequence number, with sequence number 1, and router 2 have also received last message from router number 1 with what sequence number, with sequence number 1. So both router have exchanged their sequence number also. Fine. Third thing that will happen in this state is MTU size negotiation. As I told you that MTU is also one parameter of OSPF neighborship, like MTU must match. So MTU will check in this state, X start state. Let's say if MTU inside this the data DBD message of R1 is 1500 byte, and MTU over here in the DBD of router 2 is 1400 byte. So neighborship will stuck in this state. In which state? X start state. And sometime interviewer can ask you this question that my OSPF neighborship is stuck in X start state. What can be the reason? So reason can be what? MTU mismatch. If MTU will mismatch, definitely neighborship will stuck in X start state. Fine.
So if MTU mismatch occurs, so in which port will be stuck in the extra state?
Which port?
Yes, between the router 1 and router 2.
Where is port? Means
Like,
fast Ethernet. Let's say
yeah.
this is fast Ethernet 0/0.
Yes, and that one is 0 by 1, can I consider? So if
No, let's say router ID of this router is 1.1.1, router ID of this router is 2.2.2. So neighborship between 1.1.1.1 and 2.2.2 will stuck in X start state. Here if you will run, see, let me show you practically also here. On router number 1 and on router number 2, on both router, first I am going to remove OSPF configuration. No router OSPF 1. On router number 2 also say no router OSPF process 1. And this time I am going to change the MTU of fast Ethernet 0/0 of router number 2. Here say IP MTU and 1400 byte, let's say. Fine. And now again I am going to configure router OSPF process 1. Let's say router ID 2.2.2.2 and exit interface fast Ethernet 0/0 IP OSPF 1 area 0. On router number 1, router OSPF process 1, router ID 1.1.1, exit interface fast Ethernet 0/0 IP OSPF 1 area 0, and so IP OSPF neighbor. So neighborship is in two-way state now. Just wait. So IP OSPF neighbor. Both are saying DR other.
yeah, it is moved actually. It is when to exchange.
See here.
Yes.
On router number 2, neighborship is stuck in which state?
Extract.
X start state.
And one is when to exchange, right?
Yeah, this router actually router 1 have moved their state from X start to exchange, so that's why here state is exchange, right? But if MTU will mismatch, neighborship will stuck in X start state. Fine.
Okay, got it. It will stuck in extract only.
Now
And
if neighborship is stuck in X start state, means OSPF router cannot exchange database, because till now till X start state we have not discussed any exchange of database, means router have not exchanged database till now, right? So okay, let me move to next state first.
Can we give
Yeah.
MTU ignore?
Yeah, we can.
You mentioned
we can
about this.
we can we can tell to router also that please ignore MTU, right? Do not match MTU, but by default MTU is one parameter of neighborship. Okay,
You mentioned the sequence number, right? What is the significance of that? That will be acknowledged or something?
sequence number.
Yeah.
No, wait, we will discuss about sequence number more. Like if router 1 have sent one sequence number to router number 2, that let's say I have sent my database to you with sequence number 5, right? So next time again, let's say router 2 is receiving one update message from router number 1. It will check first sequence number. What is the sequence number inside the database? If sequence number is higher, then only router 2 will process that update. If it is receiving the update message with same sequence number, that means their database is already updated,
Okay. Okay.
right? So that's why we are using it. We will discuss more about sequence number later. Fine. So till now, uh, down state, init state, two-way state, and X start state. Till here, in these four state, any question? In this state, guys, in X start state, there is one more thing will happen. That is master and slab election. OSPF routers are going to exchange their database. So which router will send their database first? For that, we have again two types of router in OSPF. One is master, one is slab. Master router will always initiate sending database, right? So in access start state, one router will become master and one router will become slab also. Fine. Router with highest router ID will become master. So in this scenario, between router 1 and router 2, which router will become master?
R2.
Yes.
Router 1 will be the master because router ID, highest router ID is for router 1 is this one, dot 1.
Highest router ID is of router 1 or
No,
router 2?
R2, R2.
R2 because you have
Router 2.
configured easily.
2 na? Yeah.
Sorry.
Okay. No problem. Okay. Now
But
the
sir,
next
the
state is, yeah.
sorry, the election process will take place in the two-way state, right?
Which election?
DR and BDR is not the same as
Yes, DR
master.
and BDR election will happen in two-way state.
Okay.
Guys,
This,
in exchange state, yes.
yeah, in this MTU negotiation, it's exchange, right? Okay.
X start.
X start. Okay. Okay.
So in the extart, I mean, if the MTU parameter is not matching, it will stuck up in extart. How about the other mandatory parameters? So I mean, is that only for applicable for MTU alone?
Router ID must be same. Hello time, date time must be, router ID must be unique. Hello time, date time must be same. Network type must be same. Area ID must be same. MTU must be same. These all are parameter.
Okay, so all these parameters will try to match in this X state. If at least
Yes,
one is
here
not matching, it again it will loop in that X state, X start, right?
if MTU will not match, then it will stuck in X start state. Only MTU.
Oh,
Like if router ID is same on both router, then OSPF neighborship will not come in init state, because router 1 will not accept the hello message of router 2. So neighborship will not come in init state from down state. Still neighborship state will be down. Fine. Now guys, actually see, this message was empty message. This DBT message was empty message. It was not carry header also. In exchange state, it will send same DBT message with LSA header. With LSA's header means network header, header of database description, right? So router will send header of LSA. Database is nothing but LSAs. Router store LSA link state advertisement in their database. OSPF router never share network information. Like, let's say here I have two router R1, R2. Fine. Router 1 have one loopback. Here I am running network 10.1.1.0/24. If we will run EIGRP here, EIGRP will advertise this network information to their neighbor with the help of update message. But in case of OSPF, router will not advertise this network information to router number 2. First, router 1 will put this network information in the form of LSA in their database, and router will send this database to router number 2. Router 1 will send this database to router number 2, and router 2 will calculate the cost for this network. It will decide which path is the best path for this network, everything. Inside the database there will be information of link. So OSPF routers share link information. If I will inside the database of router 1 there will be one LSA. Let's say there is one LSA1. Inside the LSA1, how many link router number 1 have? 2 link. This is, let's say, fast ethernet 0/0, and this is loopback 1. So there will be information about both link, fast ethernet 0/0 and loopback 1, like what network is running on fast ethernet 0/0, what is the bandwidth of this interface, means what is the cost, what is the network type, detailed information of this link and detailed information of this link, what network are running on both interfaces, what subnet mask is running on both interfaces, right? These are the information inside the LSA, and LSA are inside the database. So router 1 is actually sending the all link information to router number 2, to their neighbor, all link information to their neighbor. Fine. So first in X start state it will send empty DBD, database description, empty. This is just for bidirectional connectivity. You can say to exchange sequence number for the master and slab election. In exchange state it will send header, like inside the database how many LSAs are there. Fine. So exchange state will carry what information? LSA header, means type 2 message. It is type 2 message, means type 2 message will send in exchange and X start state. DBD is type 2 message, second message in OSPF. So if someone will ask you that type 2 message will send in which state, so type 2 message will send in 2 state, X start state and exchange state, correct? Now loading. So router 1 have sent their header of LSA. Let's say router 2, the router 1 have sent header A, B, C, like I have network A, network B, network C. Okay, and router 2 have already network A. Router 2 don't need network A information, right? So router 2 will send what? Request message for B and C. For B and C it will send request message, that is LSR message. LSR, link state request message. In which state? In loading state it will send LSR. And when router 1 will receive LSR message for BC, it will send detailed information of B and C in the form of LSU message. LSU, link state update message. And when router 2 will receive link state update message, it will send acknowledgement message for these two LSA. These three messages will exchange in which state? In loading state. And if router have exchanged their database, then state will move in full state. Full state means database has been exchanged between two router. Okay. So OSPF never ship can stuck in loading state also. If if there is, let's say, some problem with hardware, because of that router is not able to send LSU message, LSU link state update message, the never ship will stuck in loading state. Can neighborship stuck in exchange state, guys? No, right? And full state means database has exchanged. Fine. So now question is type 1 message. Type 1 message will send in which state? Hello message. Yes, tell me.
Sorry, sir. What is the question?
Hello message will send by router in which state?
Down
Initial
state.
state.
Down.
Need
All state. All state. Hello message is used to discover neighbor and keep alive. After full neighborship state, also router will send hello message, right? Okay, type 2 message. DBD message will send in which state?
like after 2A.
Exchange
X start
and
And extra.
exchange.
and exchange. Okay. Type 3 message, that is LSU, LSR.
Loading.
Loading.
Loading, very good. LSU,
Loading.
Loading.
loading, very good. And LSAC,
Loading.
Loading.
loading, very good. So these are OSPF neighborship states. Now any question?
Just to
Gee,
reconfirm, this DBD header will be sent in X start stage, right?
Right.
So
No, empty DBD. In X start state, empty DBD, null DBD.
okay,
Header will be in exchange state.
okay. So based on that header, I will look into the safe router one.
Yes, let's say I am telling you that I have some network A, B, C, and you have already A network information, right?
Okay,
So you will
okay,
request me for B and C. Then I will send you detailed information of these two network with the help of LSU message,
okay.
link
So I
state
will
update
send
message.
information only for the ones which are requested. The other
Correct.
information I will never send.
Correct.
Okay, thank you.
Gee, in that
Uh,
extract stage, you are saying like master and slave election will be happen, right?
Hmm.
Yeah, in that on which parameter it will be elected as a master and slave?
Router ID.
Only router ID only.
Only router ID.
If that router ID is matched means
Router ID is means router ID will be unique, na? Router ID must be unique.
okay.
So each router in OSPF domain will have one unique router ID.
Okay.
Sir, sorry, can you slightly
Yeah.
explain once again about that X start and exchange?
X start, in X start state it will send null DBD, and in the exchange state it will send header of DBD database. In both state it will send DBD message, database description message, that is type 2 message in OSPF. But in X start state it will send null empty DBD just to exchange sequence number. Okay. And in exchange state it will send header of DBD LSAs. First understand LSAs, automatically these things will clear to you, right? Just this is just one overview of states, okay? Automatically day by day you will understand everything, because there are lots of things we are going to understand here. LSA, database, how many types of LSAs are there, right? I will capture the packet also between two routers to see these messages, okay?
sir, in which cases we receive the sequence number mismatch?
We will not receive sequence number mismatch, brother.
Not receiving, right?
Right.
I'm not sure. Let me check.
Okay.
Even after the full state, we will be receiving LSAs, right? For updates. No.
Right. Whenever change will occur in the topology,
Okay.
definitely it will send LSU message, link state update message.
So we will not go back to the state, right? We will, the state will be
Yes.
full only, but we will get only
If
the.
a state is full and then you are, let's say, changing MTU, also it will not impact in neighborship.
Okay, okay.
Once neighborship state will come in full state, doesn't matter you are what value you are configuring to MTU or rest parameter.
Okay.
Now LSAs. How many types of LSAs are there in OSPF? So first of all, let me do one thing. Types of LSAs. Number one. Yes, guys. Type 1 LSA is
Router LSA.
type 1 LSA is router LSA. Second one is type 2. Type 2 LSA is
Network.
Network.
network LSA. Type 3
Summary LSA.
summary LSA. Type 4 type 4
That is also summary LSA. ASBR.
Summary is
ASBS.
ASBR summary LSA.
Yes.
Type 5
ASPR.
External LSA.
external LSA. Type 6 type 6 not in use. Type 7
NSSA.
NSSA LSA. External LSA. Type 8 type 8 not in use. Type 9 not in use. Type 10 not in use. Type 11 not in use.
So where
Fine.
it is used
Okay.
actually?
Type 10 LSA is type 6 LSA is MOSPF LSA. In Cisco IS does not support type 6 LSA. We use LSA 10 or 9. LSA 10 and LSA 9 is opaque LSA. We use it in traffic engineering,
Okay.
right? To share external information. Those are very advanced things. You don't need to understand it. Okay. For you guys, you need to understand LSA 1 to LSA 5 and LSA 7. These 6 LSA. LSA 1 to LSA 5 and LSA 7. We need to understand these all LSA. Now, first is router LSA. And you know, there will be two information in all LSAs. In all LSAs, there will be two common information. First one is advertising router ID, and second one is link ID. Link ID. All LSAs means LSA 1 to LSA 7, all LSAs will carry these two information, advertising router ID and link ID. You will see advertising router ID will be always the router ID of router who is advertising that LSA, right? Like in this scenario, you can see in router 1 database, we can see database of router 1, so IP OSPF database. So inside the database, there is only one LSA. There is only one LSA of router 1. and this is router LSA1, right? Why it is not receiving LSA1 of router 2? So IP OSPF neighbor, because neighborship is stuck. Let me do one thing here. I am going to change the MTU again, interface fast ethernet 0/0, and here I am going to remove this command MTU, say no to this. Now OSPF neighborship will come up in full state. Just wait. So IP OSPF neighbor, fine. So now neighborship is full, and now if you will check database of router 1, so IP OSPF database, you can see inside the database of router number 1 there are two number of LSA1. There are two number of LSA1, that is router LSA. This is LSA1 of router 1, this is LSA1 of router 2. And as I told you that in each LSA there will be two information, advertising router ID and link ID, right? This is router LSA. In router LSA also we are able to see advertising router ID and link ID. This is network LSA. In this LSA also we are able to see advertising router ID and link ID. Fine. So all LSAs will carry these two information, advertising router ID and link ID. Advertising router ID will be always the router ID of a router who is advertising the LSA, and link ID in some LSA will be the router ID of advertiser router, and in some LSA link ID will be network information, right? Or it can be IP address. Like here you can see an LSA 2 network LSA. Link ID is the IP address of router 2 and advertising router ID is 2.2.2.2. Fine. Okay, so keep this in mind that each LSA will carry these two information, advertising router ID and link ID. Advertising router ID will be always the router ID of router who is advertising the router, and link ID will be sometime IP address. It can be sometime in some LSA's router ID, or it can be network information. Okay, now let me start LSA from type 1 LSA, that is router LSA. First one is router LSA. So yes guys, what is router LSA? Anything about router LSA? Router LSA, type 1 LSA, it is router LSA. Every router in OSPF domain, every router in OSPF domain, every router will generate a router LSA in OSPF domain. Like in this scenario, you can see both router is generating LSA 1, router 1 also, router 2 also, and see the database of router 1. This is database of router 1, and you can see the database of router 2. So IP OSPF database. There is no any change in the database of router 1 and router 2. Database of both router are identical, right? Same, exactly same, right? Inside the database of both router there are two LSA1 and one LSA2. Fine. So here I am talking about router LSA. So both router are generating LSA1. Each router in OSPF domain will generate LSA1. This is first point about router LSA. Each router will generate this LSA. Fine. Then LSA1 or we can say LSA1 or router LSA can be flooded within area. LSA 1 cannot cross area, right? LSA 1 cannot cross. Guys, these points are very important to understand OSPF. Must tell you, let's say here I have router 1, router 2, router 3. Okay, these are connected like this. R1, R2, R3. Fine. Let's say this is OSPF area 0 domain. Here we are running OSPF area 0. Here we are running OSPF area 1. OSPF work on the basis of area. In upcoming day, you will understand area also. Let's say this is area 0 and this is area 1. Area 1. So LSA 1 of router 1 cannot enter in area 1. LSA 1 of router 1 cannot enter in area 1, or LSA 1 of router 3 cannot enter in area 0, because LSA 1 cannot cross area. LSA 1 can be flooded within area, right? So let's say here I have one network 1.1.1.1, and on router number 3 I have one network 3.3.3.3. So through LSA 1, router 1 and router 3 cannot exchange these prefixes with each other. It is not possible, right? If I will talk about router 1 LSA, router 1 database, so tell me guys, inside the database of router 1, how many LSA 1 will be there? Router ID of router 2 is, let's say, 2.2.2.2. Inside the database of router 1, how many LSA 1 will be there?
2.
Two LSA.
2. One of 1.1.1 and one of 2.2.2.2. Correct? Inside the database of router 2, how many LSA 1 will be there?
2.
2. 2.
R2 and R3, right?
No.
R2 will receive LSA 1 of router 1 or not?
Sorry. Only R3. So that is 3.3.3.3.
1.1.1 will be there. LSA 1 of 1.1.1, LSA 1 of 2.2.2, and LSA 1 of 3.3.3.3. Inside the database of R3, there will be LSA 1 of 1.3.3.3 and 2.2.2.2. Yes or no?
This R2, it is not area specific.
Yeah, LSA, you know, these two LSA 1.1.1 and 2.2.2 will be in area 0, and 2.2.2 and 3.3.3.3 will be in area 1.
Okay.
But how many LSA 1 will be there? My question is this: how many
Okay.
LSA 1 will be there inside the database of router 2? So there will be 3 number of LSA 1.
Oh yes, I got it.
Okay. So first thing about LSA 1 is LSA 1 cannot cross area. Okay. So between two area, we need different LSA. That's why we have type 3 LSA, that is summary LSA, right? Okay. We will discuss it. Now, what more about this LSA? See, let's say here I have router 1, router 2, R1, R2. Here IP address is, let's say, 12.1.1.1. Here IP address is 12.1.1.2. On router number 1, we are running one loopback 1.1.1.1. On router 2, we are running one loopback 2.2.2.2. Fine. So in this scenario, both router will generate LSA. What is happening here? both router will generate LSA1. Let me talk about the LSA1 of router 1. Inside the LSA1 of router 1, this is, let's say, LSA1 of router 1. LSA1 of router 1. There will be advertising router ID. Advertising router ID. What will be the advertising router ID?
1.1.
1.1.1.1. There will be link ID also, link ID. Link ID will be the the router ID of router who is generating LSA1. In LSA1, link ID and advertising router ID. In both field, there will be information about router ID of router who is advertising the LSA1. Fine. So link ID in link ID field, value will be also 1.1.1. Got it? After that, there will be information about link, that how many link are there. So let's say like link 1 is fast Ethernet F0/0. What network is running here?
12.1.
12.1.12.1.1.0. What is the cost on this link? 64, or let's say 1. This is fast Ethernet link, like this. Then there is one more link, link 2 loopback 1. What network is running on this link? 1.1.1. Let's say 0/24/24. Here also slash value will be there. It's 24, like this. And then cost, let's say 1. So like this. If there are more links, so there will be more information. Here I can open LSA1 of any router in details. Like you can see router 1 database. So IP OSPF database. Inside the database of router 1, we are able to see 2 number of LSA1. This is LSA1 of router 1, right? Inside this LSA, how many link are there? 1. Router 1 have only 1 link. Because here I am not running, I think, loopback. So IP interface brief. I'm running loopback, but I have not advertised this loopback in OSPF. So that's why it's saying only one link information are there inside the LSA1 of router 1. If I will open this LSA in detail, so IP OSPF database, if I will open this LSA in detail, we can see the detailed information about this LSA, like so IP OSPF database, and then I want to open router LSA and router LSA of 1.1.1.1. So you can see this is detailed information of LSA1 of router 1. So there is information of which link, which net. This is designated router ID, okay, backup designated router ID, interface, IP address, fast Ethernet 0/0, advertising router ID, link state ID, number of link. So link connected to transit network, directly connected network. Link ID, designated router ID. On this link, who is DR? On this link, what is the IP address? Right, so these are information. If I will advertise loopback also, let me do one thing, interface loopback 1 and say IP OSPF 1 area 0. Now it will do what? Router 2 will do what? So IP OSPF database. It will add this link also in their LSA1. Now if you will open this LSA in detail, so IP OSPF database and router, let's say 2.2.2.2, you can see inside this LSA1 there are 2 link. One is stub network, directly connected network, and where we are running this IP address, and one link is transit network, that is fast Ethernet 0/0, where I am running this IP address 12.1.1.1. 2, right? So router 1 router LSA will be generated by all routers in OSPF domain. It cannot cross area, it can be flooded within area, and router LSA keep information of links, keep informations of links. Like if router 1 have 10 number of link, so it will add all links in their LSA 1. Okay guys, now what we can do, we can perform on practical of it with 3 routers like this: router 1, router 2, router 3. Tomorrow we will discuss about LSA1 detailed information like transit network, stub network, right? Designated. First of all, I think so we should cover DR and BDR concept, but while discussing LSAs, we will cover DR and BDR also. But tomorrow we will perform this lab, so you guys can also design this lab in your GNS3. This will be my lab for tomorrow. Here we will run one LAN network, let's say 10.1.1.0/24, 20.1.1.0/24, and 30.1.1.0/24. This router have, let's say, router ID 1.1.1, 2.2.2.2, and 3.3.3.3. So this time, let's say these all routers belong to belongs to single area, let's say 10. These all routers are in area 10 or in area 0. So router 1 will have how many number of LSA1? Router 1 will have how many number of LSA1?
3.
3, sir.
Okay, in this domain, how many total number of LSA1 will be there? Total number of LSA1?
6.
6.
All router will have 3 number of LSA1. So total number will be 9. Right? There will be 3 number of LSA1 inside the database of all routers. So total number of LSA1 will be 9.
Yes, yes.
And tomorrow you will also understand that how a router can design an entire topology by checking their database. Like router can design this entire topology by checking their database, right? Complete topology. So we will see that also, right, in next class. Today guys, if anyone have any question till here, please ask. Otherwise, that's all for today. Tomorrow we will perform this lab, then we will move to next LSA, that is which LSA? Network LSA.
Sir, one general question, sir. What are the disadvantage of OSPF?
Disadvantage of OSPF can be, it need more CPU, it need more RAM. These are disadvantages.
Any
It
other?
is slow as compared to EIGRP.
Okay, and in the case of RIP, you can use 15 hop count. So in the case of OSPF, any TTL value or something is used, any limited number?
You can use 255 routers, na?
Okay, okay. So that is in IPv4, right?
Right.
Okay. So that is also one kind of disadvantage we can consider.
So you can you can't you connect more than 255 routers, otherwise how end user will communicate? If you have connected more than 255 routers in a series, and one source is connected with router number 1 and destination is connected with, let's say, after 3 hop away, so will they can communicate?
Like sequentially it
Can
is
they?
connected, right?
Let's say if we are running OSPF here between these 300 routers,
Okay.
can my end user communicate? No,
Oh yes.
because end user have to generate packet with what TTL value more than 300.
By default it is 250, right?
So, yeah, it depends now again on operating system. So you have to design one operating system who should use TTL value 300 or something like that.
Oh, okay, sir. So any other thing?
Any other disadvantage?
Yes.
No, I think
Okay, sir. Fine.
each routing protocol have advantage and their disadvantage, right? We are using routing protocols on our requirement. Fine. Like we are using BGP also, and there is disadvantage of BGP also. We have disadvantage of OSPF also over EIGRP. We have advantage also, we have disadvantage also. So totally depends on our requirement. Okay guys, then I'm sending you the recording.